Okay, I guess it's time to turn off the music and to start today's live stream. So welcome everyone to the 108th in this live stream. Yes, welcome. Today's moderator is Foxtrot Charlie. You can see his nickname here. So if you have any questions for me, you actually need to either reach out to Foxtrot Charlie because he can take your question and put it on my question list, or you can just write !Q and then the question, and that will also reach my question panel so I can answer your question. I'm sometimes looking at the chat, but it's safer to make sure that I actually get the question if you either reach out to our moderator or write !Q and the question. Well, I guess if you're watching this for the 108th time, you are pretty tired of hearing that, but yeah, I know there are a lot of new people as well, so welcome. And today's topic is going to be, well, second part of GW Basic actually. So what's a GW Basic? To basically give you a recap if you were not here last time, and last time was what, a month ago, right? So GW Basic was a basic interpreter, editor, or like the whole environment actually written by Microsoft, I don't know, in the 80s basically. It was initially written for the IBM PC BIOS, so if you didn't have an operating system in your IBM PC, it would just jump into Basic Interpreter, same as happened on like Commodore, Amiga computers and so on. That actually also was the case on early PC computers. Now they later moved that out of the BIOS into DOS operating system, which well, stands for Disk Operating System. Anyway, and that was its own executable, and that was also the third basic variation which I've learned when I was learning programming, and that was in the early 90s or late 80s even. I think it was early 90s, I'm not sure. Like, it might have been 89 as well. Yeah, in any case, Microsoft open sourced it a couple of weeks ago, well, more like almost 2 months ago now. And I decided last live stream to basically take a look at it and maybe see if we can compile it, if we can run it in any way. Well, obviously you can just download the binary of GW Basic and run it in DOSBox, but I wanted to have a go at compiling it. And then I decided to make it complicated, to complicate it for myself, because why go for the easy route if we can just make it complex, hard, and learn a couple of things as we go, right? So what I decided to do is I decided to basically tokenize the source code, and the source code is fully in assembly, by the way, in 16-bit assembly, which is like super early x86 assembly. Yeah, anyway. So yeah, so what we have started writing last time was basically a Python script, which well, starts to tokenize it. The idea is to basically tokenize it. Tokenizing something means like splitting it into meaningful parts. Like, for example, if you have a programming language and there's you have a statement like a equals 5, that's actually like 3 tokens. That's a as a variable name, then the assignment operator as the second token, and the third token is 5. So from text, you will want to go to basically a list of tokens before you can do anything more with it. And after that, I still don't know what I'm going to do after that. Actually, there are a couple of things, a couple of ways we could go. One way we could go is to well, basically, one way we could go is to compile it from there. Basically resolve all the macros and all the non-simple assembly stuff, bring it to simple assembly, and then assemble it using Keystone or whatever other assembly language. And then we are met with a linking problem, so then we link it. And then we get a DOS executable, basically. The other way we could approach it is to either try to emulate it, which is doable at the end of the day, and or we can try to transpile it or cross-compile it, well, compile it actually from the assembly language to a high-level C language, and then compile that C language into a modern platform. That might be tricky or might be easy depending on how hacky the code was, and knowing programming back then, the code is probably very hacky. If we would go that route, the issues we will deal with is basically input and output, like how are they interacting with the operating system for reading files, writing files, for displaying stuff in the text buffer, because originally it was a text buffer. You just written stuff to memory or called the BIOS, and it would display stuff on the screen, right? Now we would have to write a whole interface for that, a rather simple interface in all honesty, to get a text mode or to get a graphical mode. So there's that. There's also like the keyboard input, which would be probably handled either directly by hooking the IRQ or rather the interrupt of the keyboard in that code. Currently, we obviously have much more complicated interfaces, or simpler interfaces, depending on how you look at it. Much more complicated in terms of how much code is actually executed, much more simpler in terms of how do you actually use them. It's much more simpler for the programmer to use them. So if we would go for the emulation or like transpilation route, then we will have to handle that. And yeah, we might just do that. But regardless of which path we choose, we need to first write the tokenizer. So yeah, today is going to be about writing the tokenizer. And because I haven't learned any tokenizing library, as usual, I'm going to write it from scratch. So yeah, it's basically a show today of how not to do it, but how it works internally, as usual on my live streams. I guess the opposite would be to me reading the documentation of some tokenizing libraries or parsing libraries, which I would like to avoid on live streams. Yeah, I'm rather sure you wouldn't appreciate me reading documentation. Cool. We will start as usual around like 15 minutes after the live stream started, so that means that would be in 8 minutes. So if you have any questions, just type !Q and then the question, or reach out to our moderator, Foxtrot Charlie, who will also grab your question, put it on my panel. I think there are a couple of other moderators in the chat as well, so maybe you can grab them as well. Perfect. Now let's go to the typical news stuff I have for you. Oh yeah, here we go. I'm trying to basically, oh yeah, this is a request for you, everyone watching, and I'm going to post this link. Actually, I'm going to ask Foxtrot to post this link under the video description as well. But this is, I'm basically trying to make a list of communities, forums, and like magazines and other stuff for programmers per country, like not in English, but in the native language of a given country. It could be English, of course, but usually it's not. And yeah, I'm just basically trying to make a list out of that. I know there are a lot of communities like that in Poland. I know some international ones, of course. I have absolutely no idea if like in random countries what kind of communities exist. So if you could fill out this form for your country, that would be pretty amazing. You can fill it out a couple of times. And yeah, then I hope to, if I get enough data, I'm thinking of actually publishing it. So if you are like from a country X, you could look up like, hey, what are the known communities, no programming communities, where do programmers hang out basically in my country. So, you know, if you're looking to chat about programming, you can basically go there. This is mostly about programming. Feel free to like post links to security stuff and so on. I will filter it out later, or probably like make two lists, maybe a second forum. I need to figure that out. But I would be really grateful if you could fill out that form basically. I have already, I think, around 20 answers on that form from, I'm going to check which countries I have already there. I have Poland, Turkey, Israel, Germany, France, Hungary, Italy, Romania, Morocco, Norway, Egypt, Albania, Finland, Czech Republic, Brazil, and Netherlands. So if you are from one of these countries, absolutely please fill out the form as well, because the more data I have, the better. So thank you very much for that. Now, where's paged out? Yeah, I'm still doing the review center. This is my excuse for the last 3 months. I'm really close to finishing it. So yeah, I hoped it would be already finished, but yeah, whatever. We'll get there. This is, by the way, the official splash screen of the review center. Like when you actually try to log into the review center, you get like I think this part of it. But since we basically ordered a custom splash screen, this is by the way made by Refind, the same person who did the first cover for the page out #1. I decided like, let's just ask for a full wallpaper, so this wallpaper is going to be published in a couple of days, probably on the page out website as well. Now, speaking by the way of the website, I did one minor change here. Why does zooming not work? Okay, let me try to fix the keyboard zooming. Anyway, here, this part, the link stopped working for the email group for some reason, and for the RSS and Atom channels, this is fixed now. So if you tried to subscribe to the notification emails for Paged Out, or tried to subscribe to the RSS or Atom feeds for Paged Out, then just try it again, basically, because it's fixed now. Sorry about the issues. I'm going to post the links as well, just in case. Okay, then, oh yeah, Poning online. I'm basically doing a conference in Poland every year this is the 5th year. We are doing it online this year around. It's in Polish mostly, but we are also looking for English speaking speakers. You don't have to be British, you just have to speak English. And we just opened the call for papers. So if you're interested in speaking online, so you can just talk from home, then feel free to submit. The form is both in Polish and in English. And then we will basically try to choose the best talks from there. I'm also going to give you the links. It just started. I think it's running until end of July. And big change. There are 2 tracks now. One is for security and one is for code, like programming. So if you want to talk about programming, then that's also an option now, because it's security and code in 2020. But something like we can experiment with this. I would love this conference to be in English someday, but not yet, sadly. This is the other link for the other CFP for the code one. The previous one I gave you was for the other one. Okay, then, I'm going to give you the link to the GW Basic repository from Microsoft. And as you can see, it's just like assembly files, basically. But before we get there, I'm going to take a look if you have any questions, and then in 2 minutes, I guess, we're going to start. So there's one question. Again, if you have any questions, do ping Foxtrot Charlie or do write !Q and something. Do hackerspaces count? Yes, absolutely. Hackerspaces also count. Okay, first question from VM Protect. Any clue on not being satisfied on finding a bug? I found a great exploitable bug, but I need an info leak, but I just don't want to find it. Oh, yeah, well, welcome to, I guess, 2020. Yeah, back in the days it was easy. You just found a bug and it was immediately exploitable. Nowadays, if you want to actually exploit something, you need to find like 5 bugs. Or like, usually at least you need like some kind of a write vector and some kind of a read vector. So yeah, I mean, that's kind of unescapable now. Yeah, if you want to write an exploit, then you do have to find that bug. I don't think there's any way around it, I'm sorry. I know that that's not the answer you counted on. On the other hand, you can also, if you don't want to write the exploit and you just care about like CVEs, for example, then you can just report it now already, and even without it being exploitable, you should still be able to point out it's actually triggerable and actually a vulnerability at the end of the day. But yeah, nowadays you have to chain up exploits. Like, if you look at modern browser exploits, they're like commonly a couple of bugs, one after the other, from like a renderer up to actually escaping the sandbox. So it got a lot harder, which is good. I mean, from a security perspective, right? It's good. Okay, Eridanus Supervoid writes, hi, let's imagine that you have no source code. How do you evaluate which arguments of particular function are under your control? Well, if you do you have a binary? If you have a binary, you can reverse engineer it, and if you can reverse engineer it, then well, that's the same as having the source code, basically, right? It's more work, more time. At the end of the day, there is little difference. There's some difference because actually, the lower level code you are looking at, the more you see actually what's going on there. So if you have like assembly code, you know what's going on there. If you have C code, then you need to also take into the account how the compiler might treat that code, because what the programmer meant is not always what the programmer gets, right? That's how C and C++ work. Yeah. How do you evaluate which arguments of a particular function are under your control? That's a hard one, because you at the end of the day, it's a lot of just reading the code. You have to reverse engineer it, you have to read the code and trace like the paths how you can get to that function, and then also write a POC which reaches more and more into the code and finally reaches that function. That's a lot of work, a lot of reverse engineering usually, and I don't think there are any shortcuts there. Fuzzing can kinda help you. Stuff like anger can help you a lot if it's able to generate a proof of concept for you. But I think that's about it, actually. You can also try, like, if you can actually trigger it, right? You can try with a debugger and see when it crashes, see what registers do you control and what's on the stack and which part of that do you control. But yeah, apart from analyzing it, there is no... I don't think there's a shortcut. Piotr Stelmaszek writes, any ideas about hacking IL to CPP games, especially Maze, Follow the Rabbit? IL to CPP games. What are IL to CPP games? I have no idea what's that. IL to CPP. That's Unity. Oh, no. Okay, that sounds like Unity. Especially Maze, Follow the Rabbit. That sounds like something Life Overflow did recently, right? He started playing with that, I think. Anyway, I have no idea. No hints, no tips whatsoever. Sorry, I just have no idea about it. Is taint analysis the only way to at least semi-automate that? Taint analysis is still dynamic analysis. I don't think that's the only way. The thing which anger does is the second way. But in general, yeah, it's kinda... If you want to automate it, that's kinda... I would say taint analysis is one of the best ways. It's pretty complicated to do it correctly, but yeah. Okay. Yeah, if you can do taint analysis, that's a really useful tool, so absolutely use that to the full extent. Perfect. I guess we can jump into coding in that case. Let's see what we had. We had this code. What did this code do? If I remember correctly, let's open actually one of the basic files as well. We are opening all the files, but we are at the end opening GW main as well. Here we go. Actually, this code is like 108 kilobytes, I just noticed it. But the whole code is 1 megabyte. There's 1 megabyte of code here. Yeah, I'm just like checking if... Yeah, that's 1 megabyte of code. 1 megabyte of code, back in the days, that was a lot. Like, and by a lot, I mean in the 80s, 83 especially. I'm not sure how they stored it. Did they had like early hard drives? Because a lot of floppy disks then had the capacity from like 360 up, and there were... I'm not sure if in 83 already they had like 1.2 megabyte diskettes, like floppies. Maybe they did. But yeah, like in 89, well, okay, I'm from Poland, and Poland was behind the world due to, you know, the Iron Curtain and other stuff, right? So, yeah, but in 75, I don't know how they stored it. That's a good question. I'm pretty curious if they stored the code on one floppy disk or like somewhere else. Anyway, this is basically the code. What we have done so far is basically we didn't do any tokenizing at all. What we did is basically stripping out the comments. This is the only thing we did. And yeah, so now we need to do tokenizing of all kinds. And I'm going to actually run it. What kind of Python is that? Is that Python 3? That absolutely looks like Python 3. Yeah, Python 3, absolutely. So, okay, let me open a Linux console in that case. Sorry, that's no, that's 108 kilobyte, not megabyte. Did I say megabyte? If I said megabytes, my mistake. It was 108 kilobyte. It's still pretty large as far as single files and source code go. Okay, yeah. Now we get something like this, and we are only going 50 lines into the file, which is fine. Okay. So yeah, now what we are doing is removing the comments, right? So, and are we doing a good job in removing the comments? I'm not sure if we are doing a good job. I might remove it later whatsoever, but for now, I'm just going to leave it like that, and I'm going to absolutely ignore this. I think we wanted to remove comments like this, basically. But I'm going to absolutely remove it because we are going to write a proper tokenizer as well. So yeah, like whatever, I'm going to leave this, and instead I'm going to write, because yeah, we are doing a white space separation, and this is not what we want to do if we want to write a proper tokenizer. So what I'm going to do now is here comment when we remove it, blah, blah, blah. I might remove it fully later. If we get an empty line, we sometimes do continue. Okay, if it's a comment, we basically do a continue. Otherwise, that's fine. So here we have a line, right? We sometimes get here, sometimes we don't, but sometimes we do get here. I'm going to ignore the tokens, and I'm going to go for like tokenize ln, and I'm going to mark here to do like assign it to something, and we do tokenize and line. I'm wondering about doing per line tokenization. Should I do actually everything at once, like the whole file at once instead? I might change my mind later. For now, I might be going with per line tokenization, but I don't know, I might not change my mind, we'll see. subttl, what's that? General storage management routines. Subttl, is this like a comment? Subtitle? I don't know. That's weird, like, because this absolutely does not look like a normal argument. This looks like a normal argument in assembly, right? Yeah. Okay, well, whatever. Cool, so tokenize line, and we are going to do it character by character, basically. Or rather, we are going to do it, we are going to create a set of functions which will grab a certain token for us. So we are going to do it in this way, that we are going to try to determine what we are looking at first, and then we are going to try to we need to determine what we are looking at the beginning of a line, I guess. So we might be looking at the beginning of a line at a dot. If we encounter a dot, we know it's going to be... No, I think we always at the beginning of a line actually get some kind of a keyword. No, it's not always a keyword. Sometimes it's a label, sometimes it's something else. So we're going to have some fun trying to determine the type of a token, but that's for later. It's not for now. For now, we just need to, I think, split it into simple tokens, and then we are going to combine it into meaningful tokens. So we are going to do it two-step. Yeah, so the first thing we do is we get... Okay, the first thing we are going to do is I'm going to stop actually to write out anything here. I'm going to remove this. I'm going to remove this. And I'm just going to print here. Okay, perfect. Now what I want to know is, do we ever start with... okay, this got me worried for a second there. Let's do it again. Okay. Sometimes we get a label starting with 2... No, that's fine. Okay, so first we are going to get a string. A string, the line always starts with a string, and the string always ends with either a space, either a semicolon, sorry, that's a colon, of course, or is there anything else I can see here which is weird? Oh, this is absolutely weird. Because this is like, there is no space after it, it's just like a quotation mark immediately. I'm wondering also, are these tabs or are these spaces? I don't know. They might be tabs actually. What's going on here? Subtitle, yeah, but that's pretty, I'm pretty sure that's like subtitle. I have no idea what's page, I have no idea what subtitle is. But that subtitle part might be useful for debugging later. Okay. Cool. I'm going to uncomment this again. So I'm going to start each tokenization with... okay, I need to get the length of a line, so that's going to be a z. That's length of line. I need to get the current index, and now I'm going to go with a get... I'm going to call it like get identifier, perhaps. Okay, get string... yeah, like identifier. Or constant, immediate. No, that's not immediate. So get string. ID or get ID. I guess it's a little bit simpler. I'm going always to start with this. And hope I will not fail. And I'm going to pass it 3 things. I'm going to pass it the line, I'm going to pass it I, and I'm going to pass it the size. Now what I will expect to get from it is I'm going to expect to get from it the new I, so that's going to be like new I basically. The actual token we get from it, and the token type, I guess. Like the simple tokens, let's go like a S token type, and then we get do I need the size of it? No, I don't. I think that's enough for me. Thinking about it takes a while now, but it will get easier later as we have like kind of a design going. I of z. Okay. And now this is quite easy because we just loop until we run out of characters which we deem okay. And the characters which we deem okay are okay, like what kind of characters do we deem okay? Let's make a set out of a list actually. There was something like string in Python, right? String. And I never remember it, but there's like upper, ASCII upper ASCII. Dear string. No, it's ASCII uppercase. Okay, here we go. That's yeah, that's what I meant. So we want ASCII uppercase. We want ASCII lowercase, and do we want, what else do we want? We obviously want this. Do we want digits? That's a great question. Are there any identifiers which have digits? Are there any assembly instructions which have digits in them? I don't believe so. I might be wrong, but I don't believe so. But okay, we'll need it for identifiers, for like stuff like this, for labels. And they are using this ins86, which we already established is probably just emit a byte for me. So yeah, we are going with digits as well. That string digits. String dot digits. Okay, and then some special characters which we already established. That's only, I think that's only this. Because we are going to break on this, we are going to yeah, I think that's it. So basically what we do is while I don't know if I should actually grab, yeah, I'm not going to pass the size here. That's not complicated, that's not overly complicated. I'm just going to grab the size here again. It's a constant operation anyway. So why I is less than a z, we do it like this. Oh, we need to accumulate the data somewhere. So that's like a token as token. It's going to be I'm going to start with a list, and then I'm going to append to the list, and then I'm going to just join the list. Oh, perfect. It's kind of lagging. Well, can I just do upper on everything? No, I don't want to do upper on everything, because I think it's only upper. But just in case they have some lower, or they do have some lowercase somewhere. It's in comment, but maybe there are other places where they use lowercase as well. Anyway, so yeah, back in the days, as you can see, and that was pretty typical back in the days, you only were using uppercase. Nowadays we code with lowercase, almost only with lowercase, but back in the days in the 80s and early 90s, well, actually mostly in the 80s, you were coding with only uppercase. And that was the default mode. When you booted the computer, you had like uppercase stuff, so that's why all this code is in uppercase. If you look at basic code from like Atari or Commodore, almost everything is in uppercase as well. Okay, if a given character, so if line of I is actually the character, so let's do it like this. If ch is in our character set, chars set, yeah, this is char set. Then we just append it to the stoken, so stoken append, and we give it well, we append ch, and then we increment the I and continue. If it's not there, we actually bail out. And by bail out, I mean do a break. Okay. And now if okay, so there are two things that might happen here. The token might be empty. Where do you want to handle stuff like that? Let's handle stuff like that immediately. This is going to be not good for me later on, but okay. So if not as token, which means the array is actually empty, as in we didn't get any strings, and we should get a string each time, then we do, if not as token, we do sys exit like error on line, and this is the problem because we do not know which line this is, so I'm just going to pass the whole line here. This decision is bad. Because the low-level function should never decide to exit the process, but this is a hackish code anyway. Who cares? Otherwise, we return with, and we return with the new I. So that would be the I. We might have exited this loop for two reasons actually. One reason is because we reached the end of it, and the other is because we encountered a character which is not in our list. So that's why we need the I. In either case, we need the I because we need to continue processing from there. Then we need to, well, the token, and then the token type. And the token type, we are going to define some token types. Like str_id. Was the string? Oh, just ID, just identifier. Yeah, I don't want to, I probably should name it string or something like that, but I don't want to name it because that will confuse us between actual string and like an immediate string value and this thing. Cool. Yeah, ID, like, let's just do it like this. And this is the type. Do I need to? No, I do not need to return anything else. Perfect. So here we, yeah, we did this, and now we need to decide what to do next. So, oh, we by the way, we do need absolutely a list of tokens. So we do two things here. We actually, oh, we need to do this. We can assign it directly to I. Ident. Yeah, ident I think might be better. I was wondering about ident too. So let's just go for ident. I see on chat you're proposing also to go for ident. It's also not a great name, but naming is hard. It's one of the problems in IT, right? So let's just go for ident. We need to fix it here as well. Okay, and before we do anything else, let me just like do this and see how many crashes we get. Okay, because we forgot about the dot. So there might be a dot at the beginning, and that's fine. I'm actually going to add a dot here. Okay. And now I forgot the join. I did say, kept repeating I'm going to do a join, and I did not do the join. So I got lists. Wow, surprise. Yeah, okay, now it's better. And that's only for the first, what's SGS? That's really weird. SGS. Oh, that's okay, that's fine. That's absolutely fine. Let me turn off this and see if we get any more crashes on this code. We did get a crash, oh yeah, because there are some identifiers might also use the $sign, because why not? And then an error on an empty line. Why are we parsing an empty line at all? No, is there a reason why we are parsing an empty line? If not, I'll end and continue. I don't care about empty lines. No, it's not an empty line. It's a line with... Did we strip it on? Should we strip it? Can we strip it? Let's strip the line. Okay, it's pretty weird. And, oh, okay, that explains everything. As you can see, there are like null bytes at the end for some reason. So, what do we do about null bytes? Because it's only after the end. Does each file end with an end? It's a good question. I'm going to do a quick check. No. Some files end with comments, so we cannot assume that ends it. Okay. So instead, what I'm going to do here, before the strip even, I'm going to do ln is ln replace a null byte with nothing. Okay. Perfect, now it doesn't crash. And we get already the first identifier. Do these identifiers look correctly to me? They do look absolutely fine. Now the question is, what is going to be the next character? Before we jump to the next character, I'm going to get rid of all the white space, like skip white space. That's what I'm going to do here. Is like, I'm going to create a new function, which is like skip white space. There might be 0 or more white spaces, basically. Line I, and then I'm going to always return the new I, so like white spaces. Is there like string? Is there like, yeah, string white space? What is it? It's actually everything. It's like a new line, a new line here, a space, a tab. This is what, a vertical tab probably, and the other one, I have no idea. What is the other one? This is a great mystery, great question. Wiki IBM 479. I don't remember which one is it. That's probably not this one. 437. Yeah, that's okay. That's a Polish one. Let's go for an English one. And character OB is that's not helping. Wiki ASCII. It's not helping. Okay, here we go. B and C, vertical tab and form feed. I have no idea what's form feed. Okay. But that's fine. So yeah, we actually do. Is it a is it a set? It's a string. Okay, I would prefer to have a set out of it. White space set. It's a set from the string, so string white space. It's nice because if you do like a set on the like string white space, it does it by character, so it like separates the characters. I think that's because it actually does the same as list. List also like separates the character, which is actually super convenient in Python. Python's really nice for that. Same stuff as we did here. I'm just going to copy this basically. So I'm not using a token this time. I can absolutely just do this. If it's in the character set, then we do this. Otherwise, I know that we can just write this in like one while, like combine the conditionals, but it's a little bit more readable for me this way. A little bit, not a lot, a little bit. It wouldn't be wrong if you would write it a different way. Okay, so now I need to, yeah, return I, and I think that's the only thing we need to return because we are skipping a token. So now we did this, and now we are skipping a token. I'm going to put this in a loop later on, but I'm working on some assumptions right now. I'm working on the assumption that for the first token, we do not have to determine what kind of a token it is. It's going to always be, or rather, we do not have to determine what kind of non-string token it is. But if you look at these tokens, right, they can be a lot of different things. For example, if you look at this call, you know this is the assembly instruction. If you then look at like this, well, you don't know yet, but you will know soon after we find the colon that this is actually a label. And if you find this end, for example, or CSEG, you will know that these are like some special instructions. But we will handle what actual type of an identifier it is later in the second stage. In the first stage, I just want tokens. In the second, I will start collapsing the tokens and basically lifting it higher and higher to get something I can work on later. So one step at a time, one step at a time. Okay, cool. So I did this. Now I'm going to do I is skip white space of line and I. And then I'm going to... I'm just going to actually print the... let's do which Python is this. And let's do this with a space actually. And here I'm just going to do this to see what kind of stuff can I have there. SZ not defined, that's because SZ is this, and I did not copy it. Okay, KrzaQ not defined because of its copy-paste errors, typical copy-paste errors. This is string out, this was expected, but that's fine. I'm wondering if I shouldn't already start like after getting the first one, if I shouldn't, like, maybe I should already start trying to figure out what kind of stuff did I get here. Because knowing that this is a radix, I know that a number will follow. Knowing that it's a CSEG, I have no idea what will follow after CSEG. CSEG. Oh, okay. There are some just informations about the CSEG, like segment public. And then we have CSEG ends, okay. I guess this is like cseg and dseg. Where is dseg here somewhere, right? Yeah, there's dseg. Is there like an eseg? No, there's no esegs. The cseg is code segment, dseg is data segment. Yeah. And yeah, basically this might not be clear, but if we are entering a data segment, then this stuff is being emitted to the data segment, and the moment we exit it, we are back in the code segment. This might be important later on. Yeah, perhaps I should, after grabbing the first token, I should already start deciding. So maybe I should be doing this. Or rather, I'm going to... No, I'm not going to decide yet, but I need to figure out what to expect next. So it's going to be complicated. Yeah, it's still going to be... Okay, I'm going to do, in that case, I'm going to do it a little bit differently, I think. Or am I? No, I'm not. I'm still going to continue the way I described. Okay. So, cool. Let's do it like this. If we get a number, then we get grab a number. If we get a letter, then we grab a letter. If we get a special character, then we just like get that special character. So, okay, I skipped it, and now if I is okay, but before there, we need to as token. We need to add this token and the token type. So actually, I need to do it the other way. Well, I don't need to do it the other way, but I should do it the other way. Token type as token. Okay, so we appended it. Here I'm going to change it because, well, I first want the type and then I want the value. If this is not clear for you, it will start to be clear when I start to get a proper token list. Then it will clear up. So don't worry if you're currently not knowing what's actually going on. It will become clearer as we progress. Okay, if I is z, now it has to be equal z. Let's skip defensive coding. Then we just return as tokens. Okay, that's fine. Okay, but I see there's a question, why am I not using some library for tokens? I already addressed this at the beginning. Because I don't want this live stream to turn into me reading the documentation, and I'm not familiar with basically any parsing library. Otherwise, if I would know one, I would just use it, but since I'm not, I'm doing it by hand. Yeah, and yeah, a code sample is just, while I appreciate writing the code sample in the chat, but still would require me to read a lot of documentation to be able to play with it, and this is going to take 1 or 2 live streams, but it's not so bad actually. Cool. Okay, and now we are going to do a couple of things. Yeah, let's do it like this. If ch is if Python would have a switch case, this would be a proper place to use it. Python does not have a switch case. You can emulate a switch case with a dictionary, but that's a pain. And I'm not sure I want to do it. I might do it in actually. Yeah, okay, let's do it. Yeah, this is crazy, but let's do it. I as token type. Okay, and yeah, and then a dictionary, and then we select an option from the dictionary based on the next character. We already skipped all the white spaces, so we know there will be no, like a white space will not be that character. And after we select that option, we just call it with the same arguments as we called it here. Now, I'm wondering if I didn't just make the mistake. Yeah, I need to dynamically create this dictionary. So let's call this dictionary S-token selector. Okay, and what's an S-token selector? An S-token selector is going to be a dictionary, obviously, but we need to initialize it. I guess I'm going to S-token selector. I'm going to call it just like, because it's a global. Now for ch in string dot digit, then S-token selector of ch is going to be, and this is where we assign to basically a type of a character, we assign a function that will be called for it. And the function that will be called for it is called get number. Yeah, basically. Then we need to do the same for ASCII, lowercase and uppercase. Is there just like ASCII letters or something like that? There's ASCII letters. Okay, we are going to just use that. Oh, that's a mistake. Where can I copy it? Okay, that's better. Then we do the get ident thing. And we can actually do this whole dance with these additional. We basically know that an identifier will not start with a digit. A digit might be, but that's pretty common in programming languages, that a digit cannot be at the beginning of an identifier. It can be later on, but like it's same in Python, right? You cannot name a variable like 9 but you can do ASDF 9 without a problem. So I'm also working on that assumption. That assumption should be correct. Yeah, I hope it is correct. Okay. And then for some special characters for ch in, yeah, what kind of characters? Let's just enumerate them. And yeah, I think we can we do like A in ASDF? Yeah, we can do A in ASDF. So if it's, oh, it's actually, yeah, it's not that kind of in. It's like in enumeration. Never mind. That's too, in is used in two different scenarios in Python. I just got them confused. Cool. Then this, whatever stuff is there. I don't know. Let's start with these and then see what actually breaks. Get, I'm going to call it get like special. Okay, cool. Now I need to create these functions. And I actually need to, where do I need to define the functions? I need to define the functions here, otherwise Python will complain. Or if I create, no, it will be okay if I create this into a function which is called like initialize init S-token selector. Let's do it like this. Because I don't want to create these functions above this function. I want this function to be next to this, and I don't want to move this around, so yeah. So then it would be a problem of identifier resolution, but if we do it like this, it's fine. Okay. Okay. And now we go back to here, where we have this token selector, we select a proper function, and we call it based on the type of the next argument, and we call it, okay. And this is great actually, because we can create a simple loop out of that in a second. Now I'm going to just copy this part, and I'm going to create, was it get number? I believe it was get number, right? So let's do get number. Here it's only digits. We're using octal everywhere anyway, so. Characters, so blah blah blah, here token number. need number. What else will we need in a second? We will need a colon, so like a label. Let's call it colon for now. Or like, I don't know, like label select or something like that. Comment start. Okay, what I need now is I need to figure out... Oh, we will have to handle strings too. So there's one more thing here. We have this, but we also have another thing. We have if as token selector actually starts with a quote. Not this kind of quote, not this kind of quote. I know they had. And there's also, here we need an equal sign. I'm pretty sure I saw strings being used, not in comments. Well, we'll find them in a second anyway. Okay, what's going on here? Skip. Yeah, this is the kind of hacking stuff which which is going to be problematic if we are doing cross compilation or any kind of other stuff than compilation. Anyway, here get string literal. Well, get string, just get string, because we here called it get number. We can still change it to literal or immediate value, basically. Well, we can call it literal for now. If you're wondering what's that, it's basically like this one here is a literal. It's written like this. Please excuse my bad English. Cool. So now we had this number lit. Do we just return? I'm just going to return the number. I'm playing a little bit with the idea of actually parsing the number at this point, because I know everything is going to be octal, but maybe not yet. Okay, and I do need this string in that case. Here we go. Did you decide on the target architecture? No. Also, as I mentioned at the beginning, I'm decided on a couple of paths, but each of these paths requires me to have something which is already tokenized and something I can probably start resolving the macros, basically, because I'm currently not able to resolve, like, for example, here, if I have this, like, low offset roof, right? I have absolutely no way of changing this into like 12 or whatever the value of this would be, like an actually constant value, which an assembly would need at the end of the day, an assembler would need. Yeah. So we might end up writing an assembler, like an assembly compiler at the end of the day. We might end up doing something else, we'll see, but that's to decide on the next live stream, I think, or like in 2 live streams. Cool, we get the number. This is the number, then what we need to do. The string is going to be a fun one. Because, okay. The string always begins with, it's basically like this. This is what we are looking for, right? And I have absolutely no idea if they are doing any shenanigans. So yeah, let's just do sys exit line at this point, or like string, and figure it out as we go. Okay, and we can comment out the rest. It's not going to be executed anyway, so I'm just commenting it out. Okay, then we have these, like the special tokens. So def get special line I, and this is, yeah, like if it's actually like a colon, then we return line. What do we need to? Sorry, what's the format again? It's I type. Okay, so it's I, then s token, label marker. Let's call it label marker. That's a little bit better. And then the value of it. Well, the value, we don't care about the value. Value is none. There's no value. If it's what else do we have where we had okay, this is just a comment, and if we find a comment, we're just going to like stop processing. Comment start, yeah, that's fine. Then we could do a none here, and then if it's a assignment operator, then it's actually an assignment operator, and I do need to do an assignment op. Yeah, let's call it like this. Otherwise, it's like sys exit and line, because we are going into this function without actually understanding why. Cool. Let's do the assignment op here as token selector. Okay. Now let's see if this works. Obviously it doesn't, because I forgot already a colon here. What am I looking at? Or did I forget my... We do this. Oh yeah, and then we don't do here as token type. Let's do this. Actually, let's do as token and as token type. Okay. Okay, and here it says keyword error, we move traceback. That's interesting. Okay, let's see how is it going for now. As token type. Let's actually do here a space or two spaces, then do this and then do a token. Okay, this is a little bit more readable. So yeah, not trap, this is fine. I'm going to do more error checking later. What's going on with this move? Oh, right, because a move can have, yeah, that's fine. I need to handle these two brackets as well, because I'm probably going to need to handle more brackets later on, but let's handle these two for now. How is this even supposed to work? Okay, this is supposed to work. It's not some kind of a weird Python I invented, it's just like, yeah. Okay. Bracket start or left. I'm going to just go with SQ bracket. I know it's just a bracket and the other are parentheses, but I have no idea how to spell parentheses, so... Okay, let's do it properly. Fish. Okay. I do need to add these tokens though. Okay, perfect. Okay, it did not crash. Ish, didn't crash, right? Yeah, it didn't crash. Which is good. Okay, and now I'm going to put it in a loop. Now, actually what I'm going to start with is... It's pretty weird. Are there no string literals at the end? There's a number literal here. Was this a string literal? Misses. No, where's the string here? Where did it go? Sub TTL. Oh, now I get it. No. Yeah, it exited here. Yeah. Sub TTL 4. Yeah, here we go. But yeah, the subtitle thing is... it's different. Because after the subtitle, I just need to grab everything as a string to the end. So this is a special kind of a token, which I'm pretty sure I'm going to need to handle differently. We can do it in a second. Before we get there, because that's not a string literal. I'm pretty sure we are going to find string literals, but that's not it. I'm going to add something to this, so that I actually notice it next time immediately. Okay, now I can actually put it in the loop already. So while I is less than z, I do this. Actually, I do this because this is a superset of the line which I already had there. So I'm going to do this, then I'm going to do this. I can print it. I do not need this. I do not believe I need this. We can print the line, actually. We can do print this and then the line. When we print the tokens, then if we skip the... When do we need to skip the white spaces? Let's skip them actually at the beginning, because why not? If we skip the white spaces and we end up short, we go here, otherwise we end up here, and then we are skipping white spaces and going to the token. This is fine. Okay, and then at the end we do this. Tokens, obviously. Nice. No, not really nice. What happened? Somewhere I did a mistake, and I think I know where I did my mistake. I did the mistake here, because I'm returning I. I should not return I here. I should do an I increment here. Okay, that's better. Hello. What I'm missing here is actually when I'm tokenizing and I'm returning. No, here we do break. We do a break. I decided. And here we do just a new line. Okay, that's better. Okay, so we have this. This is one token, identifier radix, then we have a number literal 8, and then we have a comment. And then, yeah, and then it goes like, okay, so after we get a comment, and this is where the special handling starts. If token type is stoken start comment. No, this is actually earlier. We have to do it already here before we even append it to the to this. Then we just break. Like, we're done. But until the end of the line, we just have the tokens. So we just have the comments. We can just skip it. Otherwise, we go here, which is fine. Otherwise, we add it and we print it. Okay. 147. It says that 100 here. Token type. What? Where? What? Oh, wait. This is not basic. Even, well, it is basic, but not basic. Good. Okay, so the first line we get a identifier radix, then we get a number. That's fine. Then we get a cseg something. So we get a cseg, then we get a segment, then we get a identifier public, and then we get a crash because we got, okay, well, what's that? Okay, it seems it's sometimes grabbing grabbing like some kind of string. I don't know, is this like a different type of a string? So what I'm going to do is I'm going to actually do it like this. Here, I'm actually going to pass it to the same exact function. Yes, that's beautiful. Which is the string literal. And here I'm going to, okay, we actually, what's the number literal? Okay, and we get here, right? So we crush here, yeah, we crush here with a string. And now we have to actually implement it. So, or ASDF. And I have absolutely no idea what's the difference yet. We'll figure it out, but I do not have an idea what's the difference. I'm going to actually create two types of string literals. One with like single quote and one with a double quote. I have no idea like, yeah, like single quote, double quote. If there is a difference at all, we can always collapse it to the one-to-one token if we like it later on. Cool, so the quote actually, the quote type is going to be line of I, and then we just increment I. Okay, nice. We do need to grab this. Now I have absolutely no idea if they are going to be trying to escape the string, because always a problem when parsing strings is if somebody wants to put a quote inside, right? So like ASDF, and then for example they escape with a backspace. Backslash, if they escape with a backslash, or they could use some other character for escaping. For example, Microsoft Batch uses a caret sign for escaping, so it's unknown actually what they're using, and this is something we are going to a little bit play by the ear and figure out when as we go. Cool. Okay, so we have it. Then we go here. Okay, we incremented it already by 1, which is good because we skipped the quote. And here, if... Oh, we do not have a character set. Quite the opposite, actually. If ch is not equal to quote, then we append it. And we increment I. Otherwise, we are equal to quote, which means we still have to append it, but we do not. We still have to increment I, but we do not append it, and then we break. And this does absolutely not handle. We do not do this. We do not do this because a string could be empty, right? So we do not need that check, and we do not do anything else yet, but we do not handle any escaping. Yeah, I have no idea how they are escaping yet. We have a too small sample. Oh, and now we need to figure out the proper token type. We are going to figure out the proper token type by using this. If it's a single quote, then it's going to be this. If it's the other way around, then it's token string D. Okay. And quote was our, yeah, okay, that's perfect. And then we have this. Perfect, that's good. Okay, let's see if it works. That was one of the lines at the top. Here, we get a cseg, then identifier segment, identifier public, and a string code seg. Is that like code SG just? Yeah, that's code SG. Perfect. Okay. Then we have this title thing, and it also tries to parse. We should not parse title and we should not parse subtitle. I have no idea what should we do with that, but well, if we do it somewhere here. How do we do it? String. Let's just do something like, or maybe, yeah, like string data. For title and subtitle. Okay, so at this moment we have appended it, we printed it, and we can check if the stoken type was stoken identifier and stoken was actually title. Is it like this? Oh wait, I think I have enough space. In title or subtitle. In such a case, I'm going to actually do a special kind of parsing, which means, did we already skip the white space? We did not skip the white space. Okay, well, we skipped the white space. And we do stoken, we basically grab everything to the end of the line. Stokens append, stoken type is stoken string data, and the data is actually line starting from I until the end of the line. And we are not stripping on the other side. We do this and we break, because we just got everything until the end of the data. This is kind of a special case, but that's fine. And we should actually also print this, so let's add this printing here. I'm not happy with special cases, but yeah, it sometimes makes a lot of sense. Okay, then we get, where's the title? We get title, so we have, yeah, we have title, and then, oh, this is wrong. Oh, this is not what I needed. What I needed is... Yeah, that's better. That's just a printing error, though. Yeah, we get title, and we have this it's not an identifier. What gives? Why does it say it's an identifier? This is correct, but like this token it's not an identifier. Did I change? What's my mistake here? I do up, oh, because I'm printing this. Okay, let's do it properly. Token type. This, okay, and this token type. Here we go. Perfect. Okay, you have title, and then we have string data, and this is the string data. That's fine. Okay. If you are waiting for a question to be answered, I'm going to be looking at them like probably in 20 minutes when we are reaching the end of this live stream. Okay, this is fine. This is absolutely perfect. We have token, then a token assignment operator, and then we have a literal value. So I like how this is actually, you know what, this is, let's do this. Yeah, this is a little bit better. Now what's going on here? No, this is fine actually. Okay, I was like, yeah, what's this? But what they are doing here is they're merging bit patterns using an OR operator. So we do not know at this point, because we are only doing simple tokens, we do not know at this point, but OR is actually in this in this context, OR is actually an operand that has like 2 parameters. We don't know that yet, we will get to that later. Okay, we have this include something, which is fine. Yeah, now the comments work correctly, because after we implemented this string literal thingy, and it's not yet correctly implemented, but after we implemented this, we can finally handle the line comments correctly. Okay, this is weird, because we get a label marker here, and I don't believe this is a label marker. We need to change the label marker into like special colon after all, because it seems it depends on the context what actually is it doing. Okay, what does it crash on then? Yeah, it's a type. Here is a basically a separator between a name of a variable, a name of a global variable, or is it a label? It's probably a global label, but they do put a type next to it, so that's probably a variable after all. Okay, and it's an identifier, then a special colon, that's better, and identifier word. Good. This is fine. This is yeah, this is a mathematical expression, which is okay, but yeah, we have parentheses, we have a division operator here, and addition operator. Am I going to just call it a math op and then figure it out? Absolutely. Let's just go to math op. Okay, and what kind of operators are these? These are like plus, minus, multiplication, division. Okay, that's, I was like, yeah, do we really have like division here? That's so expensive. No, we do have, but that's by 4. That's not expensive at all. It's just a bit shift. And parentheses as well. So let's do it like this. I'm just going to call it a math operator for now, and then like we'll figure it later in the second run what actually is going on there. Okay, this is the special one. So if chn, and here we create the, we just create a string. It doesn't have to be fast. Math ops then, yeah. But we do add a parameter this time, so we actually know how to handle it. It's kind of a lazy approach, but yeah, whatever. Math ops is going to be minus plus asterisk slash and parenthesis. I hope there is nothing more, but yeah. And here, instead of just enumerating it, I'm going to do plus math ops. Okay, here we go. So here we have this assignment operator, identifier bufflan, math operator plus, math operator open parenthesis, identifier bufflan operator. Okay, I feel like we kinda got off easy with this one. Okay. This is colon. Okay, we do not have a comma as a special operator. We do need comma as a special operator. I'm just going to go with a comma. I have no idea what a comma is yet, so I'm just going to go with comma operator. Sorry, here. Like this could be easily fixed with a dictionary. We can change it to a dictionary as I'm going to add the next one. Are we going to do it then? Or are we going to do it now? I can do it now. Okay, let's do it like this. Okay, this one's a little bit more complicated, so I'm not going to change it to a dictionary. So a dictionary, then this. Okay, so return I, then this, ch, and then none. Cool. Hey, too fast. Yeah, now. Okay, that was better. A little less code, that's always good. Let's do it. Key error. Oh, because I do not have it. So let's do it like this, like. If ch and simple map, then return I, simple map of ch none. Here we go. Okay, now we got hit with a key error with an underscore. It's a token selector, we do not have an underscore. Oh, we can, wait. Yeah, here, it's just in the identifier. Well, that's easy, we can just add it to the characters which are permittable in the identifier, which is here. And there we go. Okay, and we reach the end, and we have everything parsed now for this file, but we need to do it for all the files. So I'm going to run this same stuff on all the files. Currently, as you know, we are only running it on one file. So if it's end, then yeah, let's do it on all file. And I'm going to close my eyes because I'm a little bit afraid to do it, but okay, yeah, it crashed. What did it crash on? Dev, and it's a mathematical operation. Is it? Okay, what file is it? So, question number one, what file is this? I have absolutely no idea what file this is. We can just grep for this file, I guess. Okay, it's this file. Your GIO table. And we just like look for this. What is this? I'm pretty sure that's a bitwise end actually. Ndef. They do. Oh my, what is this? I don't know what this is. Yeah, macros. I was afraid of macros. Wait, what? Really? Comment start. Yeah, you are right here. Thank you, Christian, for pointing this out. But that's a typo, which would be, yeah, that would be an unhappy typo later. Thank you. Okay, I'm less afraid of this because I'm just going to treat it as a mathematical operation. Seriously. It is. At the end of the day, it is. Okay, and then, yeah, then we get to this. What are you? This is a reference to a macro variable, I think. So, okay, I'm just going to, it's not a math operation here. Because for it to be a math operation, it would have to be two things, right? Sorry, it would have to have two arguments, but it has only one. So this is a dereference of or a marker for a variable. But I'm a little bit afraid we are actually going to use this in a... oh, this is funny. I know what this O means here. Not that I like it, but I know. For numerals here, I'm going to actually to this add this O, because it means it's octal. Do I add it here? No, I need a separate one. I don't like it, but okay. Percent up. Okay, so what do? We do here add a special character, which is a percent up, and here we do Okay. It parses. So I think the level, like first step of tokenizing is done. Now we have to do the second level of tokenizing. I'm going to look through your questions now. If we have still some time after the questions, I might do a bit of more coding, but I think I'm going to just leave it for the next stream. And the next stream we are going to lift what we have, all these tokens which we have here, we are going to lift them one step higher to actually start already understanding what we are looking at and not only having separate tokens. I'm still thinking what to do with mathematical operations actually, because there are a couple of ways to approach it, right? We can actually either just like put it in evil or whatever, right, and be done with it, and I'm kind of leaning towards that. The other way we can do it is, I mean, this code is not going to be to attack our Python implementation that was written in 83. I don't know if Python even existed in 83. I'm pretty sure it did not exist in 83. So yeah, evil is evil, but we can use evil here without being scared of it. So I might actually be using evil operator. The other way to go around it is to do it. Yeah, if we would want to do it properly, it would be a little bit nasty because we have to. We will have a list of tokens. We have to go from a list of tokens to a tree, to an operation tree, like AST basically. And from an AST, we have to either do something which evaluates AST directly, or we have to convert it into reverse Polish notation and then evaluate it. And that's not something I want to do, and I don't think we need to do it. So I'm probably going to go with evil. Evil is like eval, right? But you pronounce it evil because it is evil. But here I think we will be able to do it, to use it. Okay, let's go with questions, folks. Show. The questions will appear here. If you have any questions, you have to either ask Foxtrot Charlie to put it in the question panel, or you can ask KrzaQ. I see KrzaQ is around as well, or it's KrzaQ's bot actually. Yeah, to use the bot, you just have to type !Q and then the question. Questions. First question: is there a way to use memory sanitizer dynamically? What kind of memory sanitizer? If you're thinking about like address sanitizer kind of stuff and memory sanitizer from the, you know, ASAN, MSAN, TSAN and so on, they are used dynamically. You have to compile the code with it, but at the end of the day, it is a dynamic tool. If you mean how to use such a tool on something which is already compiled and you only have a binary, then yeah, this is a hard problem. And I don't have a good answer. Because there are a couple of problems. One of them is that these look for example, buffer overflows, right? But after the code is compiled, you don't know where there is no easy way to tell where the boundary of a buffer is, especially for stack buffers, because for a compiler, it just like you have 10 variables, right? Or 10 different arrays, but a compiler just does like, oh yeah, allocate this amount of space. And like, it doesn't care about the assembly code does not care about there are like 10 different buffers where it's just like, yeah, allocated. And then you have to start reading into the code really deep to be able to figure out, hey, these are actually like 10 different variables, 10 different arrays. One thing which you can do is you can kind of abuse compilers, like grab a function which is decompiled by IDA or something else and then compile it with address sanitizer. It is super hard to do. It is doable. At the end of the day, it is doable. But it is, yeah, it's not easy. It's absolutely not easy. It's doable. Yeah. Now, for heap allocations, it's easier because on a heap, when you allocate something with malloc, with new or whatever, you pass how many bytes you want to allocate, therefore you pass the buffer size. And then there are a couple of different heap implementations, or heap configurations, which you can use to, for example, use a page for, like a memory page for each buffer separately, fill it with some data, and then when you allocate with some random data or like ACE or whatever, but known data, and then you put the buffer, for example, at the end of a page, and if somebody gets a buffer overflow in that buffer, because it's at the end of a page and the next page usually does not exist or is a guard page or something like that, it probably will crash, which is a great signal for you. On the other hand, if it's an underflow, it will overwrite some data when writing. It will overwrite some data, which then when the buffer is deallocated, the library can check, hey, the data before the buffer actually changed. So yeah, that's an underflow bug. It doesn't work if that's an underflow read only and not writing. And there are libraries which do that for you. It's fun to implement a library like that. I've done it, I think, twice in my life, and it's a great exercise in low level, basically. There are a lot of edge cases which you have to do. Now, if you're working on Windows, there are ways to configure a heap for the given process to behave in a way which allows you to detect some kind of memory corruptions. And that kind of works like memory sanitizer then. On Linux, I think if you can compile the code, or you can just like detach the malloc which is there and attach your other malloc, there are a couple of libraries which do that. Let me do a quick check if... I think Scudo kind of does it, and if you Google for LLVM Scudo, let's actually Google for that. Scudo. Scudo was written by Kostya Korczyński. And it's pretty amazing. It's basically a secure allocator, which means that it also allows you to detect bugs, because that's why it was created. But it is a performance saver, but there are some specialized for detecting bugs. Let me do one quick query. Yeah, it's actually here. Okay. It's called libdislocator, and it's in the AFL packet. It's basically an abusive allocator, which kind of works in the way I described. It's written here. So if you can replace the malloc calls to this, and calloc calls, and like whatever realloc calls, free calls, then you can detect. They kind of act like memory sanitizer, not as good as a compiled in one, because compiled in one has access to C++ metadata, but it still improves your detection rate. So yeah, that's basically a long answer to this question. It is a hard problem. It's a super interesting problem. Revit asks, combine OSDev with compiled GW basic interpreter. Yeah. Okay. Yeah, Foxtrot says as usual that I should change this code here into user bin and Python 3 does. I have absolutely no idea what this does. I know that Dohan always says I need to do it like this. I never actually learned why. User bin and Python 3. What? Oh, wait. Up. Alright, that's fine. It just executes. I need to learn what it does. I know that it's like recommended to do it, but I never found out the reason why. Have you ever used Cutter for reverse engineering? Cutter is UI for Radari 2, if I remember correctly. They actually advertised in PageTout 2 or PageTout 1. I need to check it out. I have not used it. I have on my to-do list to learn Radari 2, but not yet. Why not use Flex and Bison? Because I never used them too much and I don't know them out of the top of my head, and I know how to write a tokenizer out of the top of my head. So again, I know there are a lot of libraries that you would normally use for tokenization. I am not using them because I do not know them, and I don't want this live stream to be me reading the documentation, which would be pretty boring actually. So I'm just going to write it by hand, because why not? But yeah, usually if you're going for a serious project, use Flex, Bison, or one of like 10 other parsing libraries. That's actually a good recommendation. Everyone who already made it today, that is a good recommendation for production code or any kind of serious project. Absolutely do it. But yeah, we are just having fun, right? So we can do it manually. Mohammed writes, do you think CTFs are actually used for a beginner learning about cybersecurity? I participated in some easy ones, but I can't understand how most of the challenges can be applied in the field. Okay, so Great question. Now, no and yes. No, because CTFs are not representative for the whole security, like the whole infosec, right? They emulate vulnerability research and bug hunting. This is basically what they do. They don't, and like pieces of pen testing as well, but pieces. So yeah, if you look at CTFs and you look at like vulnerability research, you see more connections between them than if you look at like CTFs and then you look for like, for example, typical security operations center or trying to detect if somebody owned your network. But these are like totally unrelated to CTFs. So yeah, if you want to do, there seems to be basically a connection between, if you're good in vulnerability research, bug hunting, and so on, you will be pretty good in CTFs and the other way around. But they're still a little bit different. So, are they useful about learning cybersecurity? Yes and no. Yes, if you want to go for vulnerability research, absolutely. If you're more interested into some other kind of stuff, some kind of other kind of security, then CTFs might not be the competition you're looking for. Because yeah, it's just like not about what you want to learn. And here's the thing: if you are just starting with, if you like never did anything related to programming and like other or like sysadmining or like networks, like seriously, you never done anything seriously with that stuff, and you jump into security, you're going to have a really hard time, because security is about the details which you learn during sysadmining or doing like networking or doing programming, right? So if you have a background in one of these three fields, then yeah, and you jump into security, then it's going to be easier for you. If you haven't done anything like that, it's going to be a little bit harder. You might want to start with programming. And on CTFs, after the tasks which are for like 50 points, almost every task requires you to write code to create a solver. So yeah, almost, not all of them, but almost every task. So it's good to learn, I would say it's good to learn some programming while learning security or before learning security. Some sysadmining as well and some network as well. These are like good basics to have. And then it's like when you jump into CTFs from there, it makes a little bit more sense. Obviously, CTFs also take some time to get used to, because like it's a competition. Like you need to understand how a competition works to be good at the competition. That's true for every competition. That's true for every kind of like, I don't know, exam or job or whatever. So that's normal. Wait, what does what? Okay. What does that button do? Oh, we have a button alert in our question panel, and I have no idea what it does. Why do we even have that lever? Ridanus Supervoid writes, what's your opinion about how AI may impact the security field? I don't think if you're thinking about InfoSec, I don't think the impact is going to be huge. Because AI is, like, if you look into what these algorithms can do, it's kind of detached from security. I know there is a lot of research appearing. There isn't anything yet which would be groundbreaking. I'm hoping there will be, just because it always progresses the security forward. But yeah, I haven't seen yet anything which would be super groundbreaking or anything that would suggest that we will get a groundbreaking AI applied in security in the next couple of years. Maybe later, who knows? Especially that, like, basically, like, the more companies create hardware dedicated for neural networks and so on, the more complicated the AI can be, and that also will absolutely improve. That will absolutely improve what that can do, what the AI can do. Hickenvale, are you planning to attend Confidence 2020 September in Krakow? I don't know yet. I'm on the committee board for confidence, but I do not live in Poland, so that's the problem. Depending on the pandemic situation, basically. I have no idea yet. Really hard to tell this year. Do you want to implement BIOS functionality for this? Depending which way we go, I might have to. Yes, I might have to, parts of it. But yeah, not a lot probably. But yeah, but the BIOS API is super simplistic actually, so yeah. Also been there, done that. Which file do you use to test the Lexer? I did use initially the main file. This GW main ASM, but then I commented this out and I'm testing all the ASM files. And you're saying about bmisc ASM. Let's see what's there. Oh, sorry. I said that file, but I didn't show you that file. Yeah, here we go. What is in bmisc? Okay, let's open it here. Here we go. Okay. Yeah, it looks pretty normal. Yeah, I mean, we are now parsing all files and it seems to work, right? We can actually, let's do it like this. We can do print the file name and check if we are actually parsing it. Yeah, we are. Yeah, it seems to work on it. But yeah, it's a good question. And I kind of expected that after, like, if we parse correctly GW main, then we will have issues with the other files. And that was the case, right? We had to still fix a couple of things after we went to the other files, after I uncommented it. So yeah, a really, like, spot on comment, basically, there. Magnolia Computer Science writes, are you going to stream more PicoCTF? Yes, after I'm done playing with GW Basic, I'm going back to the tasks which I still didn't finish for PicoCTF. How often you use custom fuzzers or generic fuzzers like AFL are pretty good in most cases. I use almost only custom fuzzers. Okay, a little bit of a backstory. I work in a team where there is like for multiple years in that team we had people who created AFL, like Michał Zalewski. He was my boss, actually, my manager. We had people who created HonkFuzz. We still have, actually, Robert Jagger. And we also had some other custom fuzzers. In our team, we had a lot of fuzzers created. And I'm using one of the fuzzers we created with Euro, which isn't public. There are some stuff we released about, some information about it. But one of the reasons we didn't release it is that it runs usually on a couple of thousand machines, basically. So that's a pretty high requirement, I would say. And it's kind of optimized for that kind of scale. So yeah. AFL and HonkFuzz are amazing, but remember, if you're doing fuzzing, setting up a fuzzer and starting the fuzzing, this is the first step. This is by no means the last step in fuzzing. What you have to do is you have to observe how the coverage changes, where the fuzzer gets stuck, and then analyze that and figure out how to improve the harness, how to help the fuzzer reach areas of the code which it doesn't reach. And yeah, it's a process. Fuzzing is a process where you still have to iterate and create different harnesses and so on to get the perfect coverage. Sometimes you have to comment out pieces of the code so that the fuzzer just goes somewhere deeper. It's a process. Just remember that running the fuzzer is the first step, it's not the last step of the process. Nacker TV asks, do you know any good resources about brightening obfuscated code on RE? Any good resources? No, but look on my Twitter. A few days ago, I tweeted a poll joking whether I should give a link to people who I want to scare about reverse engineering. Actually, we can find it. And that tweet contained a link to a huge repository of resources for reverse engineering. Let's just go to my Twitter. By the way, I kinda would like you to remind you to try to fill out my form if you could, like this one from this tweet. I'm going to give you a link to this tweet as well, but okay, the resources, here we go, it's this one. And this list is huge. Take a look if there's anything there. Yeah. And by huge, let's open it again. I mean huge. Like, okay, I'm starting to scroll, and like this is like link after link after link. Yeah, let's actually go to the end so we can give a shout out to the author. Yeah. BBNFOSEC, like, thank you for creating and compiling this list. It's amazing. And it seems it was like, yeah, a year ago, but somehow I think I found it on Twitter, or somebody posted this link on our chat. We have a Discord chat, by the way. If you are only on our YouTube chat, you can go to my blog and then to About Me here, and then there is a link to a Discord chat. And there are, I think, like around 400 people on that chat, so a lot of technical people. And we do chat sometimes about technical stuff. Most of the time, in all honesty. Who cares? When will you have the next driving exam? Okay, yeah, so this is a nice question. Yeah, if you're on our chat, you know I had one driving exam already, which didn't go too well. And yeah, I'm going to have another one next month. We are pretty serious about the exams actually here in Switzerland. And I don't mean that about the requirements, but about how many attempts you can have. And it's quite interesting. So yeah, hopefully next month. It might be delayed if I figure I still need to learn more stuff. This is funny because like I never really needed to do a driving license because like I always lived in countries basically which have good or great public transport. So yeah. Okay, is the code of this YouTube bot available? I don't know. I don't think so. You have to ask KrzaQ about it actually. Masakra writes, what do you think about Apple switching to ARM processors on their computers? Do you think other companies will follow them? This is a great question, but it's the reverse as usual. As in, other companies are already on ARM. Like, think about Chromebooks, they're on ARM. Think about Microsoft Surface, that's ARM. And Apple is only now switching to ARM. So it's the other way around. It's like not other companies following Apple, but like Apple seems to be following other companies. Yeah, ARM is pretty popular, and I think one of their ideas, like that's my take on it, is that they already are maintaining parts of the kernel on iOS on ARM anyway, so, and they have a lot of experience about ARM, so yeah, why not just switch MacBooks to ARM as well. I'm really curious about OS X on ARM, and another thing to add is that historically, MacBooks weren't, like they didn't start on x86, right? They were on PowerPC for a long time, and then they switched only to x86 in 2000 something, if I remember correctly. And now they are switching to another platform. That's pretty interesting. I'm quite curious about that. And the last question probably of the day, that's, have you ever struggled against control flow integrity? I've heard that modified drop, which is called loop-oriented programming, is a complete workaround for CFI, including heuristic checks. No, in honesty, I didn't play with CFI too much yet. But yeah, this is something again on my to-do list. Good to know. I need to take a look about what's loop-oriented programming about. I don't believe I've played with it. So yeah, thank you for the comment. It's really useful. Okay, folks, I think that's it for today. So thank you for being here. Thank you to my moderator, Foxtrot Charlie, for being here, and other moderators in the YouTube bot, Foxtrot writes that the YouTube bot source code is on KrzaQ's GitHub. So go to KrzaQ's GitHub and yeah, Okay. So thank you. See you probably next week. I hope next week, or in 2 weeks in the worst case scenario. And happy hacking, happy programming. Please fill out my form. And yeah, see you. I'm going to leave you with some music as usual. Bye bye.